Okay, so this is kind of like a friendly intro problem to figure out the angular momentum of the system about the origin when you have two separate particles. So this is kind of talking about how a particle with a linear velocity, so if we're just given a linear velocity, how we can figure out angular momentum given a linear velocity of something sort of that's like spinning around tangent to a system. And we'll do some other problems that kind of like show a little bit more complicated approaches, but let's look at this guy first. Okay, so our general equation for angular momentum, we have L is equal to IW, right? And we have these are both particles, right? So this is like a point mass. So we know that I for a point mass is equal to mr squared. And then we have to figure out what that r is, right? So we have mr squared, right? Just subbing in I for a point mass. Then for something that's rotating, well, we can model something with a tangent velocity. We can take the angular velocity and we can turn it into a linear velocity by taking the tangent velocity divided by the radius, basically. So if this is some v tangent, right, that's moving around, we can relate that to the angular velocity by dividing it by the radius that it's rotating around an object. So yeah, in this case, we can do Vt over R, right? Subbing that in for W. And then we can get this expression that we'll see commonly for angular momentum for these point masses rotating about a fixed point. And we can simplify that, and we're going to end up with mr times this tangent velocity, right? The velocity tangent that would be causing the rotation. Okay, so we want to find the angular momentum of the system when the speed of each particle is 5 meters per second. So this is like pretty symmetrical here, right? They have the same velocity, so we can actually just combine the masses here and do this pretty simply. We could do it in two different ways, right? We could add L of like 3 kilograms plus L of 4 kilograms, right? We could add those two together to find the L total, right? Because they're also acting in the same direction. We wouldn't have to look at the difference there. So yeah, so in this case, the total mass equals 3 kilograms plus 4 kilograms, right? So mass total is equal to 7 kilograms, kg. So we found our total mass. Okay, and then the tangent velocity for both of these guys is equal to 5.00 meters per second, right? Tangent velocity for both of these guys. And then we have all that we need. And then the radius is the same for both of them. It's going to, so we're given the diameter, right? We're given the diameter, and so the radius is going to be half of that. So radius is equal to 1.00 meter over 2, which is equal to 0.5 meters. Okay, cool. All right, so with all that information, we can just use the expression that we figured out, right, for these point masses with a tangent velocity. And we're just going to plug in what we have. And so we have L is equal to the total mass, 7 kilograms, right? And then our radius is 0.5 meters. And then our tangent velocity is 5.00 meters per second. Okay. And then our final answer for this guy is going to be equal to, so 17.5. And it's kilogram meters per second squared for the units here. So quick question, what is our direction here? So we have, this is our X, and this is our Y. We talked about rotation, right? So if we have this in a clockwise direction, it's negative. And negative is what? Negative is in the negative Z technically, right? Because it's into the page. But in this case, when we're going counterclockwise, we know that it's positive, right? So if it's positive, think about our hands wrapping around what direction. So put your kind of pinky along the rotation, right? Curl along the rotation, and we see that our thumb would be pointing up, right? Up and out of the page. And so this would be in the positive Z hat direction. our final answer would be in the positive z hat for this angular momentum, right? So there would be like this L vector, the direction for the L vector would be pointing straight up. Okay, so we're going to go ahead and use this in some of our other problems.